Okay, hello everyone. My name is Wang. Currently, I'm a PhD student under the Department of Civil and Environmental Engineering in UW Medicine. The topic of my research today is automatic recognition of construction workers' hand gestures based on wearable sensors. Over the past decades, construction robots have gained substantial efforts due to their potential to improve the construction industry. Advances in robotics make it possible for workers to work collaboratively, for workers and robots to work collaboratively as a team. This collaboration lightens the workload of the workers and allows them to focus on the tasks that cannot be easily performed by the robots. For worker-robot collaboration, human-robot interaction is very necessary. So one of the critical steps to promote worker-robot collaboration is to provide a user-friendly interface to support their interactions on construction sites. So far, many efforts have been dedicated to the design of human-robot interfaces. Among them, hand gesture is an effective channel in the noisy construction environment. They could aid the workers to receive the correct directions without the need for complicated devices. The wearable sensors could help us to capture and interpret the hand gestures. That's why there are so many previous work about hand gesture recognition based on the wearable sensors. The sensor-based methods for hand gesture recognition can be divided into two categories. The first category is traditional methods. They generally relied on handcrafted features such as time domain and frequency domain features. These features would be fed into a machine learning classifier to obtain the final classification result. The second category is the methods based on deep learning. They have become the mainstream in the hand gesture recognition. Different deep learning architectures have been developed to achieve a higher accuracy and also a faster response. These methods have various applications, such as to identify the sports referee gestures, to understand the sign language, and also to be designed for human-computer interaction. Although the performance of the existing methods for hand gesture recognition is promising, they are not well prepared for being used on construction sites. It may be due to the following reasons. First, the commonly used hand gestures in construction generally belong to large motion gestures, which involve the swing of both hands and arms. This characteristic has not been fully tested in the existing methods, since they mainly focused on the identification of subtle motion gestures, which concentrated on only the hand movements. Second, the existing data sets were typically captured when subjects were sitting or standing still. It is still not clear whether these methods would work when the construction workers are moving and making hand gestures at the same time. Therefore, this research intends to propose a wearable sensor-based system for automatically capturing and interpreting the hand gestures of workers to support their interactions on construction sites. This figure shows an overview of the proposed system. Specifically, the raw signals coming from the wearable sensors are firstly pre-processed for synchronization and also the normalization. Then a window slides through all the incoming incoming signals, and the pre-processed data of the latest window are fed into the FCN-based classifier to achieve the hand gesture recognition. Next, I'm going to introduce these three parts in detail. In data pre-processing part, the sampling rate of different sensors is firstly synchronized to a unified sampling rate. And then the Z-score normalization is employed to reduce the impact of noise. As for the window sliding, the sliding window with fixed length is used to divide the data as shown in this figure. When the signals coming in, the window moves through the whole signals, and the pre-processed data in the latest window are fed into the FDN-based classifier. In the last part, FDN is selected as the classifier since it illustrated a higher accuracy on the multivariate time series classification tasks compared to other deep learning networks. As for the triggering mechanism, if the highest probability of the classifier is more than a threshold, the identification of the hand gesture will be triggered. The next part is the results of this study. To create the data set, a type strap 2 is selected as the wearable sensor. There are 5 3-axis accelerometers and 1 MU in the type sensor. So there are totally 21 signal channels captured by the sensor. The maximum frequency could reach up to 200 Hz. As for the dataset characteristics, the dataset contains 8 classes of hand gestures, such as stop, hoist, lower, etc. These gestures are selected since they are commonly seen on the construction sites. There are totally 192 gesture samples in the dataset, and the duration of each gesture is 10 seconds. This figure shows an example of the signal values for one gesture. As for the recognition performance, in the training phase, the ratio of training site to validation site to the test site is 4 to 1 to 1. And this figure shows the loss reduction of the classifier along the training process. In the testing phase, the precision, recall, and inference time are selected as the evaluation metrics. The precision is defined as the ratio of true positive to the sum of true positive and false positive. And the recall refers to the ratio of true positive to the sum of true positive and false negative. And the inference time is the processing time of a trained model to make a prediction. The final experimental results are shown here. As we can see, the inference time of the classifier could reach to 0.14 seconds per gesture, and both the precision and the recall of the classifier are 87.5%. Also, this video shows an online testing of hand gesture recognition for human-machine interaction. The online testing was conducted in the lab environment to interact with the truck model using the proposed system. Specifically, a subject was asked to perform the hand gestures wearing the type sensor, which was connected with the computer using the Bluetooth. The captured hand gestures would be fed into the system and processed there in real time. When a gesture was recognized and interpreted, the corresponding meaning would be sent to operate a truck model remotely. The last part is the conclusions. This research presented a wearable sensor-based system for hand gesture recognition in construction. The proposed system consisted of 3 components, which are data processing, window sliding, and FCN-based hand gesture recognition separately. The test results show that an inference time of 0.14 seconds, a precision of 87.5%, and a recall of 87.5% could be achieved. And the online testing indicated that the system has a potential for human-machine interaction in construction. As for the future work, more construction hand gestures will be included into the existing data set to make the training and the testing of the classifier more robust. Thank you.